is I'm going to make a what can be for some people a very bold claim in this video. My claim is very specifically that LLM models are not going to be the future or the present when it comes towards actually getting functional API calls and doing functional tasks within a IT based environment. I think it will be AI based. I don't think it will be LLM based. So, with that being said, with my bold statement being said, let's back out and get to how exactly I get there. And then, so kind of starting off with what got me to create this video. I'm going to shout out this particular person here. I'll leave a link to their Medium article in the description. I think it's very well written. I don't know this person, but like I came across their article. It's really well done. So and I like what they did, right? So and I've experimented in their same way before. So their article is create an AI team to manage your YouTube channel, and so they created an AI team using Crew AI, and a lot of people are big on Crew AI right now, right? You'll see a lot of videos on this, and then with me, the very first thing that I like to do when I'm approaching these things, I'm approaching them not from the research perspective, not from, oh, okay, this is the cool shiny toy. How much is this costing me? That's my very first question, right? And then that is overall like the big argument as to why I don't think that LLM models are going to be the future or the present within this, because it's just so expensive in order for an LLM model to do it. And there's no reason to take on that expense, which is contrary to anything to business 101 is if there's not a reason for the expense to happen and the expense can happen in other areas, then it's going to happen in other areas. That's my flat out logic here. But so with this, it's really interesting, right? So Crew AI is an interesting tool. And then, so this particular gentleman, I think this is a good like picture as to exactly illustrating what like his Crew AI built out does. And then, so each one of these individual pictures of the competitor analyst, the ideas creator, the analytics expert, and the marketing consultant, each one of these are individual instances of the model, right? And then he goes through in this article, and then for 90% of this article is using GPT-4 for very specific reasons. And then, but so within this, so then for each one of these times, he's at least calling, in this overall instance, 4 instances of the model every single time, right? And then those 4 instances are talking to each other. So every single time that one of those instances says something, that's an instance of calling the model. And then so what does this actually mean, and how does this actually break down, right? That's kind of what I would ask first here. So let's go ahead and dive over to this chart over here. And so I think I like to look again. How much does this cost me? Let's look at the numbers. So let's look at the numbers. So in this instance where we're talking about calling 4 instances of GPT-4, and I've got this set here to GPT-4, and we want this to, these 4 instances have to talk to each other multiple times in order to pass through tasks. And then so I've read through this gentleman's article and I've done my own analysis on this, and we both come to the same conclusion, which is that in this instance, like in order to actually get what we would call a function done, you're looking in between this $2.25 range and this $4.50 range, and then about like $3.25 in general is what you'll be looking at overall for one function, for it to do one thing overall, right? And then so kind of what figures into that is that it's about 500 back and forth interactions overall between these models, and then with each of those interactions comprising about like 300 to 350 tokens back and forth, and then those back and forth interactions stack up, and then that's what your function call is, including failures in the function call, having to redo it, having to talk to each other, having to ideate. There's a lot that goes, like these models will just start going off on the tokens, right? But so when you do that, at the end of the day, you can do this, and it's cool. But putting this into pure economic terms as to where we're at right now, right? Like, let's not talk about like dream scenarios in the future. Where we're at right now, this is costing, in order to do a basic function call, about $3, which is like not economical. You could hire a VA or a like a junior admin that could do a function call as well, and it would take them, it would functionally equivalently cost you less than $3. So it's literally at this particular moment in time to do this is costing anyone money to do it. Everyone that's making these videos as to, oh, how cool it is, they're leaving out exactly how much it costs, right? Because they're only doing it one or two times, and then so that's like there's not and people that are constantly doing this because it's so expensive, right? But everyone thinks it's so cool, and everyone is that the future that the is of the mindset that the future costs will go down. But in this particular instance, when it comes to AI, when it comes to function calling specifically, no one has been able to get those costs to come down. The costs are not going down. Why that is, there's a lot of reasons why and a lot of speculation as to why, but as of right now, no one is doing it's a pipe dream to go under that assumption, just flat out, right? And then so I like to operate in the real world with these things, and in the real world, you're paying above market prices in the status quo to get an LLM model to do these things. And then so where does that leave us, right? Like so then is like AI going to be out of the function calling a game entirely? Is this that just the end? No, it's the exact opposite, right? And I think that we're now at the point, and I think this is a good point to be at, where we're starting to see differentiation between like actual experts within this and people that are GPT experts, right? And then and so if you are only focused on the LLM model and you're only focused on shoehorning this particular problem into LLM land, then you're going to run into problems overall, right? Like, so let's go back to this gentleman's article. I think this is a good place to start out overall with this discussion and dive deeper into this discussion, right? So let's look at like what Crew AI does overall. First thing is that it takes agents and it has them, it breaks them up into tasks and it gives them tools. And then so how does it do this, right? On a code level, it's pretty simple. You install some packages and then you create the agents, and then the agents, you have to tell the agents exactly what to do, right? So there's a lot of code here for the agents. This is the code just for the agents right here. And then each agent has a role, a goal, a backstory, a memory, and an allow delegation. And then so all of this for each one of these individual agents starts to get computationally expensive, right? And then you've got your tasks. And then so here's your like long string of code for your tasks. And then you have custom tools for the agent, and then here's your code for the tools that the model has, right? And then this is like the longest thing ever. And then so this is like your LLM model's toolbox. So when it wants to do a function, it has to reference all of this, right? And then you create this is for more tools, more tool code, more and more code, and then here's more code for the tools. This is all code for the tools. Cleaner data set, more code for the tools, and then same thing here, right? So like, oh my god, cool. And then we get to this, and then this is just running the main function, which should be short, cool. And then you get your results, which should be okay, cool. And then it runs back and forth, so you can see like all of the chains that happen once you execute this, right? Which is pretty cool, except for every single time this is like, think of this as like just dollar signs going off. That's what is going off in my head. Like all of this interaction and all of these talking between these models, it's just every single time they're talking to each other, it's just like dollar, 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 dollar. Stop talking to each other. Just do what I want you to do, right? But so going back up here, what we can see is like a ton of code just for these tools, and then like that's the bottom line that I want to get at. It's like 6 cells of massive amounts of code to execute these tools. And then why is it this? Because of a few things, right? It's hard and difficult overall for the LLM model to do function calling. It requires a model like GPT-4 in like 90% of instances. But then on top of that, you're putting all of this inside of the LLM model. You're making all of this the LLM model's job. So, and in order to do that, you give it a massive toolbox, and then you say, here's your toolbox. Here's how you interact with the toolbox every step of that, right? And you build all of that into the LLM model. And then so if you only look at AI in terms of LLM models, then that makes perfect sense, right? Okay, what's wrong with this overall? It's just a lot of code, right? Like what's this guy going into at this point? But if you know and you look beyond LLM models when it comes to AI, again, like what's the simplest way and the most cost efficient way to do this? And then so we come over here, and then this is just kind of code that I've played around with and built around with myself a lot. And then this is what's called a swarm algorithm. And then so if you think of like in my head, I think of an LLM model as like a big mech, like a big huge robot, like Power Rangers or Transformers type robot, right? That you like can step into, and it's just this massive beast that is like the size of a building. And then, but like swarm algorithms would be like the equivalent of like bees, right? Like they and like they or like insects that like birds that can like fly around and they're very nimble and they can go into places where the mech can't go. And that's kind of the advantage of a swarm, right? And there's a ton of them. And then so that's like when you think of swarm algorithms, that's exactly what they are. They're like very tiny AI models. So as opposed to this big mech and one huge mech, you have like like 1,000 like very 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 tiny models. And these 1,000 tiny models, they don't take a lot of resources to run. They don't take GPU to run. Like you could run this on a calculator. This is running right now on an environment with just base level Google Colab without even the GPU activated. You don't need the GPU activated in order to run any of this. And then this particular notebook here, starting off on a base level, it's just showing you exactly how swarm algorithms work. And here's, I have in this instance starting off with 3 agents. And then in this second cell, I have the agents do a little bit more complex tasks, and I show you that. And then in this cell, I add more agents as well as more complicated tasks, and then they do more things, and they can combine and do more functions. And then here is where we get into the meat, right? And then so this is what everyone wants LLM models to do, like that toolbox where you have like that massive amount of code. This is functionally what it's doing, right? It's saying, okay, so within your toolbox, essentially what I want you to do is I want you to call, there's functions called API calls, and I want you to, within API calls, there's get and put functions. And then so I want you to essentially operate within that framework. And then so you guys are going to be swarm algorithms, and then based off of this get and put logic, I'm going to give you a URL. You go to that URL and you extract all of the information that you can off of that particular URL. And then in this instance, that's exactly what it does. And then so I have it, it comes out, it has the 3 agents, and it literally, like this is live information from, like it's an example URL, right? Like for testing API calls, and then it's pulling out this data. I didn't like this is data and like from these swarm algorithms functioning, pulling this data from this URL, and it's using like no resources. Right? I could do this all day. I could run this a million times and it wouldn't cost me $3. And then so and then we can complicate this. We can add more complicated tasks and have it do both get and put functions, right? And then so this is kind of like putting it all together. And then so compared to that massive amount of code, this is my end code, right? Where I have my agents, I tell them exactly what the URL is within this code, and then all they do is they go and then they can either they can extract and input information into the URL. And then so in this instance, I have them, each one of the agents puts the ID number of the record that they're looking for in this instance, which is 1. So each one of them puts them, and then each one of them extracts different information from the record. But then from this, I get every single row of data from this particular record from my 3 swarm agents is exactly what happens when I execute this code, right? And then again, I do this a million times. It's not going to cost me $3. And then if you do this with an AI model, with an LLM model, it's going to take it minutes to execute this and to run, and then it's going to cost you $3, and it's going to get you the same result. This took 0 seconds to run when I executed it, right? And then so then your next question might be then like, okay, that's cool, but then so like can I bring an LLM model into this? Can I actually have the LLM model do that work? And the answer is yes, like flat out. So here's what I give you on top of this, right? So let's say that you want the LLM model to interact with this swarm algorithm. Very simple. This line of code right here, right? You just define a function, LLM request swarm, and you give that to the LLM model. It's part of its toolbox that you saw that they create, right? Instead of creating a toolbox and then shoving all of this into it, you say, hey, like swarm algorithms will take care of this. If you have a problem and you want to call a URL, all you have to do is give the swarm algorithms the URL, and then here's your base function, right? And then so from there you have two options. Do you want them to call like the base URL, or do you want to call a different URL? And you could access that different URL from your toolbox, for example. And then from there, it can run one of two calls, and then the LLM model could make these decisions and make this call, right? And then so if you're doing this and you're having the LLM model control this, even putting the LLM model, even if you're running GPT-4 in this, so let's say you do the swarm algorithm, and then you have GPT-4 make the final decision. It's going to cost you their combined tokens for 1,000 for OpenAI for GPT-4. It's 6 for in and 12 for out. So what's it, like 8 cents for 1,000. And then so I think this costs you about 4 cents. And then so 4 cents compared to $3. Pretty significant cost savings there, right? Every single time that you want to do this. And then that's if you want to bring in an LLM model and that particular LLM model in this instance. In this instance, then since you're bringing it external, you could look at significantly reducing those costs per token, and then you could be running this for like 4 cents for one per 100 tries or so. You could get it really down if you get it really dialed within that, and then so you can get it really cheap, right? And then so within that, like we're not talking at the end of the day in even the same ballpark or league between these two things in regards towards cost at the end of the day when you actually break it down, right? When you get beyond the like, oh, it's cool to have an LLM model do all of your stuff, it's like, yeah, that's cool, but I can have a swarm algorithm do the exact same thing that an LLM model can do, and it's going to be fractions of a penny comparatively. And then so if you like at the over long equations of this, or if you, especially if you're trying to monetize it, bring a business off of it, or anything off of it, at the end of the day, anyone that's operating off of swarm algorithms, in this instance, they're going to obliterate anyone that is thinking of in the LLM mindset specifically for these things. And I think like those are the types of equations and the arbitrage within this particular equation that exist that like people don't realize how much of this exists and like what the differences are between swarm algorithms and LLMs, and people are still stuck on LLMs. I get it all, right? And then so if that's you, these types of videos are exactly for you, and that's the type of content, and you are the exact type of person that I'm trying to make videos for at this particular moment in time. I'm trying to get you 2 years, 3 years, 5 years ahead of everyone else that's getting into this. And then so that's kind of my focus, which is a blend of the technical background and business expertise. And then so I'm trying to give you the best mixture of that with upfront and just very concise and right to the chase analysis. So if you like this type of content, please like and subscribe. Thank you very much.